All right, so today we're going to do inequalities and triangles. So this is cheat unit 5.5 for us here. And so we're moving around from the realm of the special segments into starting to look at a little more just triangles in general. And so our first theorem here is going to be basically if one side of the triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So given any triangle, given two sides or all three sides, if you know the longest side, then you actually know the bigger angle. All right, if you know the shorter side, you know the smaller angle. So the bigger angle is always opposite the bigger side or the longer side, and the shorter angle is the smaller angle is always opposite the shorter side. So we have bigger angle, bigger side, shorter angle, shorter side. All right. So in our case here, we can do an inequality of the measure of angle A is greater than the measure of angle C because BC, the side opposite of A, is larger or longer than the side opposite of C, which is A. So we have that one. And then the theorem that comes after that is basically the converse. And the converse basically says if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So it's basically our converse from what we had earlier. And so we see here that the side opposite of D, which is FE, is going to be bigger than the side opposite of E, which is DF. So we can write it out, EF is greater than DF. So no matter what, if we know any of the sides of a triangle, at least two of the sides, even if all three, we can find the longest side, the middle side, the smaller side, and vice versa, which one's bigger, which is smaller. And when we're given angles like this, guys, we can actually figure out what's the longest side of the whole triangle. So if you think about it, D is 60, E is 40. If we extenuate that, we know that F has to be 80. 60 plus 40 is 100. Out of 180 is 80 less, which means that the side opposite of F, which is DE, it has to be our longest side. So in all reality, DE is greater than EF, which is then also greater than DF. So in order from greatest to smallest, from longest to shortest, that would be it. And we also figured out the angles. And so we just did that. I asked you to do. All right. So I'll give you an example here. We're going to write the side lengths in order from least to greatest. So let's figure out our angles. And we see that our angles, we have J, H, and G. And we see that J is the largest, H is second, and G is the smallest. So to get the answer, right, let's think about it. What is the angle or the side opposite of J? And so we're going from least to greatest. We're going to go smallest order, so I'm going opposite actually. So we're going G. Opposite of G would be JH. The opposite of H would be JG. And then the opposite of J would be HG. So knowing that G is the smallest, H is next, and J is the largest, you're going to write the sides in order as JH, JG, and GH. All right, here's another example, given the side lengths. So instead of doing the angles, we're doing the side lengths. And so we want to go again least to greatest. So we want to find our smallest side. We see that QP here is our smallest side. The next smallest side would be PR, and then our longest side is QR. So we're doing the angles. We're going to do the angles from opposite of that. So the opposite of QP is R, the opposite of PR is Q, and the opposite of QR is P. So we can write our answers since we have QP is the shortest, PR the next, and QR is the longest. We can then say the measure of R is the smallest, Q would be the next, and P is the biggest. Now, this doesn't mean we actually find the actual angle measurements. We won't be able to do that for a while. Most of you guys won't be doing that for a long while here, but we can do that in the future. But for now, we can't do that. You guys aren't to that level yet. All right, so using the theorem. So I give you something like this. In the diagram shown, AB is congruent to AC and BC is bigger than AB. What can we conclude about the angles in ABC? Well, one of the great things about this is you mark up your diagram. We know that AB and AC are congruent. So what does that tell us? Well, it also tells us that the angles, because we can use the definition of it, the base angles theorem, saying that if two sides of a triangle are congruent, then the angles opposite them, so in this case B and C, are also congruent. And then it tells us that BC is greater than AB. So we know that BC is greater than AB, which also tells us that BC is greater than AC. So we also know now that the angle opposite of BC has to be what? Bigger than the angle opposite of AB, which would be C. So we know that A has to be greater than C, which also means that A has to be greater than B. So we'll get the solution here. All right. Because AB is congruent to AC, ABC is isosceles. We know B and C are congruent. Therefore, the measure of B equals measure of C. And because BC is greater than AB, then A is greater than C, which also means by substitution, we know that A is greater than B. We did all that. All right, constructing a triangle. So this is a little bit different. So when we construct a triangle, guys, the triangle is made up of three sides as we know, and I'm going to give a couple examples here. But to construct a triangle, we have to be able to enclose some figure, right? So let's think about this as a drawbridge. If you've ever gone over a drawbridge in water, you have two things from each side. And usually, like, here's your water and the bridge, they stick up in the air. And what has to happen is as this drawbridge closes, as it's going down, these parts have to match up. Now, in a normal drawbridge, they have to connect right in the middle. It makes a nice little flat line, makes the drawbridge work, right? Well, and for a triangle, we can't have it go all the way down. We can't have it be short. We can't have it be right at it equal, because that would just make a straight line. It doesn't make a triangle. It's not enclosed. We have to have it a little bit bigger than that third side. We want to have a little bit of a tilt to it so water can run off or whatever. So what we do is we're going to use this with constructed triangles. What we want to find out is, will the two shorter sides add up to be bigger than the big side? Now, here's the solution: is try drawing the triangles with given side lengths. Only group C is possible. The sum of the first and second lengths must be greater than. So what ends up happening is we have to figure out, when you add up the two shorter sides, it has to be longer than the third side. That's the easiest way to remember this. If a triangle is present. If the two shorter sides don't add up to be greater than the third side, then it's not a triangle. Don't know what it is. It could just be three segments out in space. It could be one segment on top of another segment, right? Or two segments on top of one segment. It makes a straight line. But for all the intents purposes, this is it. So we kind of give this hint, and we do these little drawings, and we see that if you were to draw this, we have 5, 2, and 2. What you'll see is that these two will not actually get back down to the 5. You get here, and you got here, and all of a sudden you got that 1 in between because it's 2 and 2. The drawbridge doesn't meet. All right, if we do the same thing, what happens with this one with 3 and 2 is that we get there and we get there, and they meet, but the problem is it forms a straight line. Whereas if you go 4, 2, and 5, we see that 4 and 2 do meet at some point, and we get our nice little triangle. So biggest thing, two smaller sides must add up to be greater than the third side. The two smaller sides must add up to be greater than the third side. It's pretty elementary. What they're going to say is that any two sides have to add up to be greater than the third side. But if you already know the longest side, it's automatically going to be greater than whatever the other two sides are. So it's always the two smaller sides. It makes it one calculation, whether or not you know it or not. All right, so triangle inequality theorem, and that's what it's called, says the sum of the lengths of any two sides of the triangle is greater than the length of the third side. So that's what we write down. It's what we call the triangle inequality theorem. Two theorems we had beforehand, we don't call the triangle inequality theorems because we're just comparing angles and sides. This one actually says it has to be a triangle. So in our case here, AB plus BC has to be greater than AC, or AC plus B, any of the two sides. So we get all three scenarios: AB plus BC, AC plus BC, AB plus AC. And again, the easiest way is, if you already know the side lengths, two shorter sides greater than the third side. It works out every time. Now, dealing with this, we also can find possible side lengths for a triangle. And so we get this. A triangle has one side of 10 centimeters and another of 14 centimeters. We're going to describe the possible lengths of the third side. Well, we got to think about it. What sides were we given? Are we given the two shorter sides? or are we given one of the longest sides and one of the shorter sides? So there's a couple scenarios we got to think about. We know 14 can't be the shorter side. It can be the longest side, but it can't be the shorter side. And we know 10 can't be the longest side in there. So we know it has to be one of the shorter sides. So our two possibilities would go from there. So let X represent the length of the third side, and we're going to use the triangle inequality theorem to solve and write the inequalities. So we got two of them, right? So the first one is, let's assume 14 is the longest side. So we know that 10 and the third side, we'll call X, has to be greater than 14. So X plus 10 is greater than 14. And then we just solve for X. We get X is greater than 4. All right. Now, let's assume that 10 and 14 are the two shorter sides. So they have to add up and be greater than the missing side, which is X. So 10 plus 14 is greater than X. We get that 24 is greater than X. But if we reimagine it the other way, we can say that X is less than 24 because we like to read inequalities from the variable perspective. So we see that X has to be greater than 4 and it has to be less than 24. So the scale or our possible answers are anywhere from 4 to 24. We don't include 4, we don't include 24, but anywhere in between. So 5, 6, 7, 8, 4.2, 23.9999. All those are good possibilities. Those will all work as a solution. So we see we can get two answers. So you will have to do this on your homework. Make sure you pay attention to it. All right. And then we get this. Solve the inequality. AB plus AC is greater than BC. All right. So we'll plug our things in. X plus 2 plus X plus 3 is greater than 3X minus 2. 2X plus 5 is greater than 3X minus 2. And so we get 5 is greater than X minus 2. So X is less than 7. All right. Does that mean all answers less than 7 are going to work? No. But anything that is less than 7 does make this inequality possible. All right. What you're also going to be asked to do, guys, on your homework is, given these three sides, they're going to say, all right, give the values of X that could possibly work. Well, let's assume that AB plus AC is greater than BC, right? Well, what happens is if we change it, we don't know all these are the third side. Now, this one's just telling us, but what if we said that, okay, maybe AB is the longer side. So that means that BC plus AC has to be greater than AB. And so if we do that one, we get 3X minus 2 plus X plus 3 has to be greater than X plus 2. And so we get 4X plus 1 is greater than X plus 2. 3X is greater than 1. X is greater than 1/3. So now we get a range. X is less than 7. X is greater than 1/3. But we haven't done every scenario here. We still got another scenario. We also have that AB plus BC has to be greater than AC, assuming AC is the longest side now. So if we do that one, we get 3X minus 2 plus X plus 2 is greater than X plus 3. So we get 4X is greater than X plus 3. 3X is greater than 3. X is greater than 1. So we see we have three different possibilities. We have X is greater than 1/3. X is less than 7, and X is greater than 1. Now, if we're looking at this in all possible realms, the only one that we know works automatically is going to be X is less than 7. It's the only one that's a less than. So that one by itself, we know it has to be less than 7. So we know our answer in general has to be something less than 7. But what do we have to be greater with? And this is where plugging in numbers can help. If you think about it, if you plug in 1/3, would you get a positive value for all the sides? And if you look at it, you get, if you plug in 1/3 for X plus 2, yes. 1/3 for X plus 3, yes. But if you plug in 1/3 for 3X minus 2, that's going to give you 1 minus 2. It's -1. Well, you can't have a negative side length. You can't have a length of negative. So this one is kind of an extraneous solution. It's unnecessary because it doesn't give us a value that can work. Even if I wasn't using 1/3 and I was using something that's a little greater than that, call it 2/3, it would still give me a section of 0, which doesn't work either. So X value has to be greater than 1. So my final answer in all this would be X is greater than 1 and less than 7. And you are going to have to do this on your homework. We have to do all scenarios. So be aware that this can happen. All right. And so your homework here, guys, make sure you're doing it. It's on your assignment sheet. Nice little comment for you guys. Can't do this. You tried it, didn't work. So just make sure you do everything. And see you guys next class.